Welcome to our channel. In today's videos, we'll show you how to build an automatic car parking system using Arduino. Today our group will explain the concept, describe the circuit and code, demonstrate the project in action, and showcase the contribution we made as a team. Why this project? Parking management is a real-world challenge, especially in crowded urban areas. As cities grow and more vehicles hit the road, there's a need for a smart, efficient, automated solution to manage parking spaces. An efficient parking management can lead to traffic congestions, wasting time, and frustration for drivers. The automatic car parking system aims to provide an affordable and easy-to-deploy solution for managing smart parking areas. It's laid the foundation for the future expansion into more advanced technologies. Objectives. First, to design and implement an automatic parking system using Arduino and basic electronic components to emphasize on IR sensor, servo motor, and LCD screen. Second, to gain practical experience in embedded system, sensor integration, and real-world automation. Third is to provide a prototype that can be enhanced with IoT features in future development. Last is to improve space management efficiency in limited parking areas. For a concept, we use IR sensors to detect the presence of a car. When a car is detected, a servo motor opens a barrier to allow entry, and after the car passes, it closes automatically. We also use an LCD I2C models to indicate whether the parking slot is occupied. Here's a short example. Let's do it! Materials. First is 1 plastic exposure board, 1 double-sided tape, 1 mini breadboard, 1 Arduino Uno board, and 1 LCD IC2 module. 2 IR sensors, 1 servo motor with DIY barrel with match from store and tape, jumper wires, and 330 ohm resistor. Lastly, the toy cars and cutter. Next is circuit diagram. Now let's take a look in detail. For the 16x2 LCD display, we first connected jumper wires female to male to VCC, ground, SDA, and SCL. Then we connected VCC to the Arduino's 5V pin and the ground to the Arduino's ground pin. SDA, the blue one, we connected to Arduino's SDA pin, which is A4, and SCL to the Arduino's SCL pin, which is A5. Next is IR sensors, which we have 2 units. It's both first connected jumper wire female to male to VCC, ground, and out, which is signal. For the left sensor, VCC and ground is connected to 5V and ground in the breadboard, and for the out is connected to Arduino digital pin 2. For the right sensor, we both connect VCC and ground to the 5V and ground in the breadboard, and out is connected to Arduino digital pin 4. Next is servo motor. We first connected jumper wires female to male to VCC, GND, and out, which is the signal. Then we connected jumper wires male to male to the servo motor. Then we connect VCC connected to 5V and GND connected to the ground, which is on the breadboard. Lastly, we connected the signal to Arduino digital pin number 3. Then we connect both grounds and 5V from breadboard to Arduino and decorate our parking lots.
Hello, I'm going to represent about my code in Arduino. Let's take a look at. First, we include the library that we need, such as y.h is for I2C communication. Liquid crystal underscore I2C.h is for the LCD display, and server.h Let's add control the servo motor. Here we create the LCD object. We are using an LCD with an I2C address of 0x27 and it has 16 columns and 2 rows. Then we create a servo motor object called myServer. Next one, we set up pin IR1 and IR2 are infrared sensor. IR1 for car coming in and IR2 for car going out. Slot tell us how many parking spots are available. We start with 4 and flag 1 and flag 2 are just stated flag. We will use 2 previous. So in the setup function, we start the serial monitor, initialize the LCD and turn on the backlight. So we set the IR sensor as input because they will detect if a car is present. We connect the servo motor to pin 4, then we set it to 100 degrees. This means the barrier starts in the closed position. And we print a welcome message on the LCD for 2 seconds. After that, we clear the screen so it's ready for real-time info. For inside the loop, we check if the IR1 sensor detects a car. If it does, and we have not already detected this car, then we continue. For the next one, we check if any parking slots are left. If yes, we lift the barrier by moving the server to 0 degree. Then we subtract 1 from the number of available slots. But if there are no slots left, we show a message saying parking full on the LCD. Then we wait 3 seconds before continue. And then we clear the LCD screen after finishing the entries detection section. And now we check the second sensor, that IR2. This one detects car leaving. If a car is leaving and we have not detected it before, flag 2 equal 0. We raise the barrier. We also increase the number of available slots by 1. And for this part, check if both entry and exit action have happened. We wait for 1 second, then close the barrier again. Finally, we reset both flags back to 0. So the system is ready for the next car. At the end of the loop, we show a message on the LCD, welcome, on the first line, and the number of available park slots on the second line, that's slot left, and followed by number.
Project demonstration. We'll start with entry. When click run the code, the LCD will display Arduino parking system. Starting with welcome slot left is 4. Now, when the car passes through the left IR sensor, 2 green lights turn on, then the servo motor opens the barrier to let the car in. And each time a car enters, LCD will show one's available parking spaces. When the car passes through right IR sensor, 2 green lights turn on and the barrier automatically closes. When the number of available slots reaches 0 and a new car arrives, the LCD displays parking full and the barriers do not open. For the exit, when the car exits and the right IR sensor is activated, the barrier automatically opens. After the car passes the left IR sensor, it automatically closes. The LCD shows that the number of available parking slots has increased.